It's a little homework help for Unit 5, Lesson 10, piecewise linear functions. Again, remind you that piecewise means that there are several pieces to the function. And in this case, they're all going to be linear. And so this is what we mean by piecewise. Pieces of a function, and it comes in different slopes. So when we talk about this one, what we're after with this first part is when we talk about what this graph shows. It shows the distance of a car from home as a function of time. A couple things to recognize is that means that home is down here on the x-axis. So they're home right here and home right here. Okay. What it means is that they left their home. They left a distance from home pretty quickly, came up to the spot, spent some time at a certain place. Maybe they're at the store, and then they came back home, not going as fast as they left. So describe what a person watching the car might see, what's going on. That's not the only scenario. It could have been they drove somewhere, parked, and then drove back. There's a lot of different options for that one. But it has to be accurate, or else it's not going to count. This one, part A, is the equation of the graph represents two functions. Use the equation y equals 4 and the graph to answer the questions. In this case, it's all about interpreting with another equation that's not written. Y equals 4 is right there. That should be enough information to help you with this equation. But when x is 4, is the output of the equation on the graph greater or less? Pick one. And then for what value of x produces the same output in both the graph and the equation, go back and interpret the equation or interpret the graph. Last one, you have a graph here and you have several different questions that'll follow to answer different things about this trip on a bike trail. And the trail has markers every 0.5 kilometers showing the distance from the beginning of the trail. So what we're talking about right here is the distance beginning in from the beginning in kilometers is you're moving from no kilometers, you're at the trailhead, and you are 3 hours out. So when you get back, so this is a round trip. It goes from here all the way back to the beginning. And we know that because the distance from the beginning is you have returned. So keep that in mind as you go through this. It says, when was the bike rider going the fastest? You need to look for the steepest slope. Because that'll tell you traveling a certain distance in the least amount of time. So look for that steepest slope. That could be positive or negative. Pick whichever one it is. When was the bike rider going the slowest? Then that's going to be the least steep slope or the most level. So we're looking for the most level slope, the one that's closest to a zero slope. During what times was the rider going away from the beginning of the trail? Not including when the rider was stopped, so only when it's traveling away from the beginning of the trail. We have to think about something right there. With the distance, we have to think about when was the distance. I don't know if you can hear that, but I keep writing faster than what the board can keep up with. Distance is what we have to consider, and specifically the distance is increasing. The next one, what times is the rider going back towards the beginning of the trail? Well, if in part C it's going away from the beginning and the distance is increasing, part D would be the distance is decreasing. Let's see if this will help. And when what times did the rider stop? You want to look for times when the time continues, but when the distance does not continue. So look for points when the distance levels out. Okay? When it's completely level, that's what will matter. And that's it. You don't have to do this last question. You'll be all done with your homework. Thanks for checking in.